Привет. Меня зовут Себастьян, и я работаю в качестве евангелиста программного обеспечения для IBM. И я учу русский, но я плохо говорю, so I think it's easier if I talk in English. So yeah, thanks for introducing me, and I'm very happy to be here to talk about design principles for the effective developer. So this is going to be a presentation of, well, not just theory of design principles and how to apply them, but basically from the experience, what do we actually need in projects, right? Rather than just doing some over-engineering type of thing, what do we actually need in project that makes our code more maintainable, more effective, better? And well, some takeaways here. So that's my name in Cyrillic, and a few Java titles involved here. I typically do enterprise software, but this talk will mainly be about Java SE, like plain Java, with maybe a few enterprise things being involved. And yeah, let's start right away with one of the things that I think are most important in computer science. Is, well, how to apply design principles and what to care about. And this talk was motivated by, well, there's many things that we might have heard of, design principles, like there's a gang of 4 pattern, they are solid, we're gonna have a look into that. Don't repeat yourself, and duplication is evil. A few other patterns we maybe know about domain-driven designs, and many more. You might invent your own principles or things to follow, and the question is now, okay, what is more reasonable? So from a pragmatic approach, from a pragmatic perspective, what do we need in projects? And one of the most important principles or concepts in IT, I believe, is the concept of abstraction. That is actually the whole reason why we can use something like computers, right? Computers are extremely complex. They introduce a lot of different technologies. And for example, I studied computer science. And to be honest, I have no clue about, or not much clue about, electrical engineering, right? Who actually knows, who of you knows how a computer chip works, right? With these AND and OR gates and things like that. Who could, well, I shouldn't raise the hand. Who could build one using the silicon? Wow, one person could build a chip. I certainly could not, right? And why is it possible that we can write programs and do stuff, communicating via HTTP, send some things over the network from here to the other end of the world? Well, it's basically that principle of abstraction, right? You use a lot of things that are abstracted away. My mom can use a phone, right? She has not studied computer science, but why can she use a phone? Well, because everything is so abstracted away that you don't have to know communication protocols, you don't have to know HTTP. When you use a browser, you don't have to know HTML, right? All of that is abstracted to make it easier and easier, to make it more abstract, these abstraction layers that build upon each other, that you can use it. The same is true in programming. And that is a very good principle, and probably one of the most important principles to follow. You abstract things, you build these abstraction layers in order to use stuff, right? So if, for example, you use a modern enterprise Java framework, you don't have to implement Ethernet frames or individual HTTP requests even. You can build upon what is already being done in a lower abstraction level, right? And these abstraction levels are, well, very important. So let's have a look into some code. I have a, Maven project, but that actually doesn't matter. I have one example that I want to show you first with tests. Why? Because I think that is always an important, topic where especially this is lacking, what I'm going to show you. So what I have, I'm from Germany. We do cars, so BMW and things like this. Imagine we would have, this is now an enterprise type of system test, but it actually doesn't matter. Imagine we would have some system where we can use HTTP to, let's say, create a BMW car, right? So how do we do this? Well, I don't know, let's have a look at the code here. For example, we can use some HTTP client to send some JSON requests and then, going back and forth, right? This is I've seen a lot of tests looking like that, right? What do we do here? Well, I don't know, this is some type of target where we send some requests. That is a JSON thing where we say, okay, in order to get all of the car orders, we would need to, get some JSON here and then extract some JSON mapping. Okay, this makes sense. And well, then we want to create a new car order. So let's say we want to order a red BMW car. That means we would need to, let's look into this method. Okay, create some JSON. So let's build some JSON with a car brand and a color. Okay, and then let's go back. In order to create it, well, we need to do some HTTP post, and then the test would verify whether that post was successful, that our HTTP client has done there, and so on and so forth. And well, what happens here? Oh, okay, we're gonna load the car order again here by doing another HTTP call that has a JSON response, and then we're gonna verify this, and then again we load all of the orders, the car orders, to assert whether, well, now we have one more order in the system, right? So basically it is a system test that uses HTTP and JSON to verify some stuff. Okay, who understood what the code did on the first time reading it? You're lying. Who thinks this is readable? Or this is really understandable what that test is going to test? Good response. So maybe if you look closely and you have 1 or 2 coffee, then you can read it. But well, what is the problem here? I would say so that is already a good indicator. I have to scroll, right? So that method here is doing too much, or it's not really doing too much. It has like too many concerns, or it has too many different abstractions, right? So what we're talking about here, that is a method that should do some testing, right? Some test scenario. And it has multiple concerns and multiple, different abstraction layers built into this one method, right? We have the test scenario, something like create, I don't know, a car order with a certain color and type and whatever, and something like, HTTP. We're talking about JSON. We're talking about HTTP status codes here, and all of that is, just merged into one method. Who has seen code like that? And not just now, I mean in a project, yeah, everybody, right? Yes. So that is basically what we're facing, and what we're gonna want to actually have is to introduce more abstraction, right? To have multiple abstraction layers and then to delegate. Why? Well, because to make it more readable. So the computer would totally execute that, right? The computer can execute all kinds of crazy spaghetti code, and I can write it once and read it never again, right? But the point is, what we should care about in projects is to create code that humans can understand and humans can read. It's easy to create complex code that computers can understand and run. Let's have another example here, another system test that has a similar method, create, verify BMW car. And now what we say, oh, I'm going to create an order, whatever that is. I have no clue, that's the first time I see this code. Order BMW red, okay, car order BMW red. And then I have something like that, it's called car order system, whatever that does, and I say create order. Okay, sure. Let's continue, car order system get order with something like URI, like an identifier, okay. So I can load and get the order, and then I say, oh, is the order here equal to what I had before, comparing these fields and whatever, and assert that get all orders contains that identifier of the order. Okay, that makes sense, right? What did I just do? I create a car order with a red BMW. I tell that system, whatever that is, I tell please create that order, and then I load the order, I get the order, and verify whether that is whatever, has some specific properties. Who thinks that is readable? What's wrong with the rest? You don't think that is readable? You want to come up stage and make it more readable? Well, I think the point is here is to see that difference in these two examples. What is the difference here? Well, I use some proper abstraction. Or basically I delegate to some, what I have here is to some delegate in order to make it more readable, in order to actually have multiple different abstraction layers. And in this method, I always just talk about the same abstraction layer. I don't talk about HTTP. Have you seen any? No, there's no HTTP. I don't talk about JSON. Did you see some? No. No JSON, no HTTP status code. I only talk on that, abstraction layer from a business perspective. Create a car, a red BMW, send it to the system, and now ask the system whether that order is in the system and has these properties, whether a red BMW car has been created and it's in the system. That makes sense, right? From a tester perspective, in this test case or in this business use case, that makes sense here, it's readable. Now, if the developer asks, by the way, how has that order been created? Well, let's dive deeper, right? Let's look into the delegate, because we delegate here to a different, lower abstraction layer to see, okay, what is that system actually doing? And in this case, we're going to see, well, this is just a plain simple HTTP client. It uses JAX as client here, and it actually does a very, very similar thing to what we saw before in that spaghetti code monster method that, well, get some orders, then we create some order, we send a request using JSON builder, we can verify something. That's all the lower level magic of, that JSON thing. What this abstraction layer does not include, it does not include my test scope, right? In my test scenario. It does not say about only a red BMW car will be created. No. I could create the system, I could use that system to create blue BMWs as well, right? Or blue something else, Mercedes cars or whatever you prefer, right? So that is a reusable component. That is basically that abstraction being built in. Now, for projects, or how do we get there, what I want to show you is what I would call think first driven development. So sounds obvious. Well, you have to think first what you actually want to do, especially when we do testing. That is a very good example, I think, when we say, oh, we want to have some test scenarios and see what we're going to do here. And why I call this that way is, well, often what I do, I just code in comments, or actually even on paper, what I want to test. So let's have another test, end-to-end test, just because then I have another name. Do I want to add the file to Git? Yeah, maybe. So what I would do in this case to say write some test, and then I kid you not, use write in comment first approach. So something like create car order with, in this case, I don't know, BMW brand and red, right? Red color. And then what else we had? Well, something like verify car order, right? So in this case, we see, okay, what do we need in order to verify the car order? I know this now looks very, very simple, but by doing this only in comments, you literally force yourself to stay on that abstraction layer first, right? Without talking about HTTP and these type of things. So in order to verify the car, what do we need? Car with order ID. Well, we need an order ID or some type of identifier, right? So then we say, okay, order ID, and now this is just pseudocode, right? This is not Java, doesn't matter. Order ID is something like, identifier of the car that has been created. And now verify the car whether, something like this, it's a BMW and red. Something like that. And then maybe we can come back and ask the system whether, that order is now part of all the orders that are returned and something like that. And then what you would do, you would replace that comment with, well, a method. Or ideally a delegate, a delegate object here, and then you call that method. So you call that method in the same way with only this information. So what is the benefit of that? Then you don't accidentally create leaky abstractions, right? Because you don't talk about HTTP yet, right? So it helps a lot if you start from a green field, to basically go from a high level and then dive down further, right, and further abstraction layers. Ideally, in delegates, in classes, you can also have, private methods. If I say, okay, now let's create a private method first, how to create that car. But if you create that using a delegate, a different class, that helps you. Why? It forces you to then keep these abstraction layers, these information in that class. Right. If I then would use some HTTP information here, it would get a compile error because it, doesn't include or doesn't import the HTTP package or something like that. So you force yourself to basically stay in that environment. And this is probably one of the most important takeaways here, to craft proper abstraction layers and to use delegation. So delegation is not only helpful for readability. I once was talking to a Java performance expert, and he said, well, in order to make your code really performant, delegate the S out of it, right? If you want to your code to perform, use delegation. Delegate to private methods and delegate, to other classes. Why? Well, that's Java JVM internals. Then the JIT compilation, the hotspot engine, can actually inline your code much better. Why? You end up with small methods, right? You saw that code. The code is way smaller. And then, you have private methods, and they're only just a few lines of code because you don't add a lot of complexity into a single method. If you have some cyclomatic complexity, right, some decision path, that is being, cut into multiple pieces into your abstraction layers, and then, outsourced, delegated to a private method, or maybe to a delegate, like a delegate class. So that is a very, very important thing to do. Use delegation, delegate to another instance, to another component. And ideally, if you start with that perspective, okay, what do I actually have from my problem situation, then you end up with abstraction layers that are quite consistent, where you don't have any leaky abstractions to the top or to the bottom, right? So that's very, very important, especially if you want to craft reusable components, right? So about these leaky abstractions, why is that important? Well, for example, if I say I had my system test here, and if for some reason I would leak some HTTP information, well, that would be a bad thing. Why? Well, we all know this, maintainable tests, right? So this is why exactly I want to show you the test example, that we are allowed to do that in a test scope as well, because in projects I typically don't see that, right? For production code, we care a lot about, you know, building these proper delegations and things like that, but then for test code, yeah, who cares? It's just test code, right? But then what happens? You have to add some new use cases, right? Now create not only a red BMW, but a blue BMW. What you would do in this case, well, you create another test method and then, you know, just change that information. What do you do in this case if you say, oh, now please create a blue BMW? Well, I don't know. I have to look through all of these lines of code and see whether stuff changed, right? Or even worse, what happens if you not only have one of these tests, but 100, and then say, oh, now please change, you know, BMW to something else. And then you have hundreds of these test methods that you actually have to look through. Or even worse, what happens in this case if HTTP changes to something else? Or JSON changes to XML or protobuf? Well, then you can throw away the test class, right? What happens if you introduce proper abstraction without leaking some details? What happens in this case if you swap HTTP to something else? Well, here, nothing, except maybe the identifier, but you could argue URI is a valid identifier. If you want to abstract that more, you could use some UUID or some just string. And in this case, here is where you do all the changes. And then if you have 100 or 200 test classes that use this delegate, well, you don't have to switch all of them. You literally have the code change just in one class. So that helps you by crafting proper abstraction layers and by use delegation. Now let's move on to another thing, domain-driven design. Who of you has heard of domain-driven design? Hands up. Okay, most of you. Who of you has actually read the book, Domain-Driven Design? Oh, a few. That's good. It's a quite long one. Who of you has read like a smaller version, like a, you know, in a nutshell? Okay, at least a few. So you should be familiar with that. So domain-driven design. Well, what I really, really like about domain-driven design, if you're into microservice architectures, that is basically, you know, it describes really, really well how to come up with what is called context maps and bounded context of applications of your microservices, and especially within the domain model, how to craft all that properly, like basically how to define what are the responsibilities of my applications, of my microservices, where some certain information should reside, where the models reside, where the data resides, and things like that. This is very helpful. So actually very good recommendation to read that book. Domain-driven design helps you a lot. But other than just from an architectural perspective for microservices, let's have a look at the code level a little bit more. So what we have in domain-driven design are a few like stereotypes or types of things, types of components. We have things like entities, value objects, and a few more. Well, what I want to show you just a few examples how to do that modeling, following an object-oriented approach, right? We want to model whatever our business domain is into the code by keeping as, you know, pragmatic and as simple as possible, but by following OO principles, right? And especially in enterprise projects, I see that sometimes being, you know, violated, that we try to do all kinds of logic in our, you know, just a service instance or what is sometimes called transaction script, right? In just one procedural approach where it just does things using some POJOs, right? What we do, let's do this first. Let's start with some entities. So what an entity is in a system is basically, well, a domain entity, a thing, an object that our system interacts with. A bottle might be an entity, a customer is an entity, a car is certainly an entity. So a car, that's a good example. Let's start with that. Let's create a car. So a car is an entity. So there is a major difference what is an entity and what is called a value object. So an entity is always an object that is identifiable by means of your business, right? If you have a customer, that's definitely an identifiable. This customer is different to that customer. That might be depending on your business domain. Sometimes you don't care. Sometimes you only care whether this customer has the same properties as that customer, right? And then the customers are exchangeable, assuming. But customers typically are not, and cars also are not. So a very important detail is whether that car or that entity is identifiable by an ID. Might be a string, a long UID, database ID, doesn't matter at all. It's an identifiable property of your car or something like this. And let's add another thing. Let's add an engine to a car, right? Let's drive around with our car and an engine. So in an engine, I already included that. Assuming, and now this is an interesting thing, depending on our business domain, assuming an engine is also identifiable. Could be, could not be, depending on what our business does. In this case, let's say an engine typically has, like a serial number, and then we change engines and we log, which one lasted how long. So assuming for our case it is an entity, it has an ID, and then maybe some other information. So that is then an entity within an entity that is called aggregate. So the car in this case is an aggregate that aggregates multiple other entities. So in order to stay consistent when, for example, we introduce some changes into our entities, into our domain, then what we typically do, we start in the object that acts as an aggregate, right? So in this case, a car has other few properties, and in this case also has an entity, has an engine entity. So if, for example, we want to modify the engine, then we do this using the car, and we hold a reference to the car object typically that then includes some information or some methods to change the engine. Now, a different example is a value object. So a value object is an object or an instance of an object where you actually don't care about the identity as long as the values are the same. So you only care about the properties. What I have here is 20 hryvnia, something like this, yeah. A bill, 20, and here another bill, 20. If I would ask you, do you want this bill or do you want that bill? Well, then of course you say both, right? But if you would have to choose one bill or the other, of course it doesn't matter. They are both, I hope, not fake, so they're both bills for which you can pay. And at a money bill, you typically don't care which one you get, and it does have a serial number, so officially, there it is an entity, officially, if you care about, how to produce bills, if you are the government. But as a consumer, you don't care, which one you get, you only care about the value of the bill. So if I would say this one is 50 and that's 20, then of course you care, but other than that, you don't care about its identity, you only care about its value. So that is an instance, that is an example of a value object, right? You don't care which bill you get, you just want a 20 bill. And in this case, well, we can create the objects slightly differently. For example, let's say our car has a list of tires, so it includes some tires. And now again, depending on your business domain, in this case, assuming I say my domain gives me the freedom that I can declare tire as a value object. So if we had the choice, then I always, of course, want to define value objects. Why? It's simpler. I can use some mechanisms in the programming language that allow me to handle that easier. I basically don't have to care about identity, right? So what does a tire include? Let's say a tire includes a width, right, and something like a speed rating. If you're into cars, you might have seen that. So, let's say I don't care which tire I get as long as the tire fits to my car and has a certain speed rating. Like these are some speed ratings of tire. Who of you has been to Germany on a German Autobahn? Yeah, then you can use this, right? Over 240 kilometer, this tire specification, that's what you want for your car. But anyway, other than that, you don't really care which tire you get, assuming that's our business domain, and import this list. And then in this case, we include, well, now in our aggregate, we actually have, aggregate car, and we have aggregate, an entity of an engine, so that's identifiable, and we have few value objects of our tires in this case. So now what we should do in this case then, well, we of course make them final, right? Because then favor immutability. If we can, we want to make these value objects immutable, right? So then you can actually reuse instances to tires as long as they match, right? Let's include some getters here. So that is a good thing, because then if we have a car or an engine, we always have to check for, identity, because we cannot just use or modify any instance of an engine that we have, because it might be the engine of another customer. But if we have money, bills, or if we have value objects like a tire, if we now hold a reference to a tire that has a certain width and a certain speed rating, we can just use that to do some calculation or to set some references and reuse, for example, the same objects. Java does that with strings, right? If we have some string, hello, that is a value object. The string is immutable. If you would modify the hello string, like hello, do something like this, to lowercase to uppercase, what you get a new instance, right? The hello instance is not modified. So if you would hold a reference to that hello, you can do that because it will not have side effects. The reference does not change. So immutability in this case is good. Whenever you can, make things immutable. So that is definitely true for whole classes, like value objects. You can make value objects immutable, and that is a good thing. Then you can create only one tire, and let's say, oh, let's have a, something like a de facto singleton pattern. Let's have a single tire of that specification, like an empty string, right, with a constant. You can do that because the tire per se cannot change, right? If you create it once, you can have multiple instances. It does not change. That's good. Now, let's talk a little bit about implementations of enterprise frameworks. So what we have. So typically what we can do with our entities, this fortunately matches very well with the notation that we have in JPA, if you use the JPA API to persist something, because actually, maybe you have noticed that before, the annotation to make something a persistent entity is, well, called @entity, right? That matches very, very well with our notation here, because an entity requires us to have an ID. If it's an identifiable entity for something that is supposed to be persisted, let's say in a relational database, we have to annotate that with @ID. I think you're familiar with that, with these APIs, right? That's JPA. If you use Java Enterprise, if you use Spring, that's pretty much what we mostly do. And that just matches very well this notation. For an engine, it's a little bit different than we would use in this case some one-to-one mapping, where we define, okay, where do we specify the ID of the engine? But then again, engine would be also an entity, because it is, in our use case, an entity. With our tires, it's different. We can, in this case, can have something like an element collection, or if we had only a single one, we could even make it embeddable and just have it in the same table. Why? Well, it's a value object, so a tire in this case does not include an ID. A tire can be something like an @embeddable and make this embeddable into another thing. Then most of the cases that works really, really well. So that works well with our enterprise framework. Sometimes we have some, well, small gotchas where, in this case, for example, if we make something final, then it's a little bit hard to create something from, reflection from your enterprise implementation, right? So in JPA, for example, this would unfortunately not be possible. So you could not make fields final because, then the framework cannot create a new instance of a tire without specifying this dynamically, right? So that's sad. But in this case, what at least we could do is making something effectively immutable. To say, okay, unfortunately we have to remove this final, but then let's say we don't introduce a setter, we have something like a private constructor with the constructor none. Let's not make this public, but private, for example, and then include nothing here. So then it's effectively immutable. We don't have any code means to change this. Of course, we can always do stuff with reflection, right? But that's not the point. But then at least our code cannot accidentally change the tire, since we don't have a setter here, for example. So at least that enables us to use it with JPA as an embeddable object, for example, and to make it effectively immutable here. All right, what else in domain-driven design? If we have things like notation of services and repositories, and also factories. Factories, can be implemented in, depending on your domain, in multiple ways. So for example, let's say a factory might be something that, depending on your business domain, creates objects based on some certain states and criteria. And now the important takeaway is it's totally valid and makes a lot of sense to say, oh, some certain factory methods actually should be part of an entity, should be part of my domain entity, like a car. So this car, I did not include getters and setters, may not only specify getters and setters, but also other things, like for example, have, let's say, create a maintenance logbook, for example. Something like this to say, create log, or post logbook or something like this, and then return whatever that is, a list of maintenance work, right? So create maintenance logbook to return something like, I don't know, list of maintenance work. So the point is, now, where do I place this method? In this case, assuming it makes sense to create this method right in this entity, because it uses, for example, a lot of low-level information of, for example, a list of maintenance work entries. So assuming every time we go to maintenance work or something like that, and then it might reuse this, use the maintenance work, something like that. Assuming every time the car gets to the car dealer, then the dealer, adds something here and stores the information in that car entity, because it makes a lot of sense. It's connected to that car. And then in this case, we won't even reflect that in the code, that we say, okay, this actually, it is connected to this car instance. So we can, store the information here, right? That's fair enough. And then also we can store, and we can create a method here. So the method uses, in this case, data that resides in this class. And this makes a lot of sense for modeling, right? More sense than to say, oh, let's create a maintenance logbook producer service that then just, does a lot of database logic. So this is more concise. So if we have the logic right here, that is more concise, and we don't have to add, another, what is called transaction script, another external entity that does that work for us. Same is true, for example, if we say, let's have a car. A car has a something like a tank fill status, right? Something like double for percentage tank fill, whatever we have, how much gas we have in our car. And then in order to, fill it up, we could say we do something like a, I don't know, car tank fill service, as something like that. So in this case, I had a car with a setter that to say, okay, now please set the tank level to a certain value. This would probably reflect what typically we see in enterprise projects, and then we have a service that implements just this logic. But if you think about it, actually it makes more sense to say, okay, we actually don't create a setter here, but we just object-oriented programming, encapsulation. We want to offer a method to say, okay, fill tank. Maybe just fill it full, or only allow a certain, fillage percentage. So in this case, then you don't expose that implementation detail, what I do here, for an external consumer. So the point why I say this is, it is not forbidden to actually include more methods here. It makes a lot of sense for an object-oriented perspective, and this is one way to, let's define this as DDD factory, right? So whenever you look at your business domain, you can ask yourself, okay, how could we model this? Where does it make sense? Where does the data reside? Where do I have my properties here? And how can I model this that I have a high cohesion of the logic here? So that is one thing, how to implement it. A service, then, a DDD service would typically be implemented. I mean, in Spring, if you use that, we even have the annotation at service. So that's also pretty obvious. That would be implemented as some use case implementation. Java Enterprise, that might be a CDI bean, for example. So, just a class without an annotation, and that acts as a service then that uses and modifies these entities, right? Same with repositories. Repository would be in component, to load some entities from a data store, like a persistent store, something like that. We know this, that might be an entity manager, for example, or a Spring data JPA repository, right? Where we can just load our entities into our service or into our business domain, where we can then act upon them. So that is just a few things how to implement these concepts within domain-driven design. slightly connected to enterprise systems, but in general, a question: how can we model something properly? So I really recommend to have a read either at the book Domain-Driven Design or at some takeaway short in a nutshell blog post or small book upon that. That helps you a lot in understanding modeling for things like where do we put some basically some procedural information, where do we put some methods, how do we implement them, and in general it makes a lot of sense to craft entity domains like classes like this that include, well, a little bit more of the logic that resides in a higher cohesion, where we put the logic that actually acts on that data, like this maintenance work or the tank fill that resides right there. And if you think about it, it actually makes a lot of sense because that follows the object-oriented design principles. All right. Let's move on a little bit more to more high level to our architecture, or how we basically model and package our application, especially with regards to Java packages, right? So there's a very good, I think it's original blog post by Martin Fowler, and I really love the term screaming architecture. So if you look into a project, especially if you're not familiar with the project, it should scream to you what it is. And I mean not the framework that you use or the Java version that you use. No, what the application actually implements, what the business domain is, that you solve. So if you think about it now from an architectural craft worker perspective, if you look at the blueprint or floor plan of a building, you typically see this right there, right? So for example, if I look into the floor plan, I think floor plan is the right word. In German, actually, we have Grundriss, which is an even better term. That is the plan of how a building is constructed. Now, if you look into a building, you don't care whether you have concrete walls or walls made of bricks or walls made of, I don't know, wood. At first, you want to understand what the building is, right? And if you look into a floor plan, you can see this, right? If you look something like this, well, this might be apartments. If you look at the floor plan of this building, if you think of it, well, it looks pretty much like have a huge hall, something like this. You have a small connecting corridors. You have, a few toilets with, multiple toilets there. Well, it looks pretty much like an event hall, right? If you look into, well, a garage that includes a car, if you look into a hairdresser saloon where you have, multiple chairs next to each other and then something like this where you can walk around, you would immediately see, okay, what is this about, right? You don't want to have the lower level information, or is the wall constructed by bricks or by stones, right? You want to see, okay, what is this about? Is it an event hall? Is it an apartment? Is it a hairdresser saloon? Is it a coffee shop, right? You would see the difference in the floor plan if you look from a high perspective, and then you can dive deeper to say, okay, actually, what is this wall being made out of, right? But if we think of enterprise projects, we necessarily don't do this very well, because then we see things like source main Java. Let's dive down there a little bit. We see things like this, right? If we look at the high-level packages, we see things like, oh yeah, that's we have a DAO package, right? This is how we typically package applications, like, or we have some entities package, something where we have to package our Java exceptions. Well, what do you see from this? What does it tell you? Well, not much. You have some REST, you have some HTTP probably, you probably have some exceptions, so you might use Java, right? Sometimes you look into the packages, and what does it scream? Well, it screams, I am a Java application, I am a Spring application, I am built with a 3-tier architecture, right? But what does it tell you from a business perspective? Well, not much. If an instance, for instance, you have another example like this, like this, well, these are other packages. This is where you package actually, well, by business domain, where you package by responsibility what you have. So not a horizontal, but a vertical packaging, where you say, oh, I have a package that says assembly line. I have a package that says car. One says maintenance. Oh, interesting. That's probably about, cars, assembles cars, and I can maintain cars. And then in there, you might find sub-packages that says, okay, here are the entities of my cars. Here is my car class. Here is my tire class. Here is my car service, maybe, or something like that, or my repository to it. So this would then structure my application in a vertical way by, again, caring about the business first. And if you think about it, this makes more sense, and this is way closer to what a floor plan of a building would look like, right? What would the equivalent of a floor plan be? Well, then I see, bricks, concrete walls, right? And then I have a package, a Java package, where I collect all my concrete walls here. Well, this doesn't tell you whether it's an event hall or something else, right? So you want to, again, craft by the abstraction layers to see, okay, what is actually going on, to understand the architecture. And that is pretty much the notation that it should scream to you what the application is about, right? You probably don't even care whether it's Java or something else by having a look at the first glance, but you want to understand, okay, what is this application actually telling me? So that is a very important thing, how to model. There are a few design approaches. For example, there's entity control boundary pattern that I sometimes use to package that then further inside these packages. But in general, you just want to care that you craft everything following the business and not everything following implementation details, right? That can come later. So that is another fun thing that I really like. YAGNI, you ain't gonna need it. Basically a principle to say, okay, if you're really not needed right now, if it's not part of the use case specification, then don't do it. That basically eliminates all of the over-engineering when it comes to architecture, when it comes to design and things like that. It's that approach to say, okay, I don't need to refactor this into packages that I don't need right now. This is not to say that refactoring per se, refactoring makes a lot of sense to improve your modeling, but this is against all of the architecture that does not solve any of my my business domain right now, or introducing some extra technology like sophisticated logging frameworks or other things that is not related to solving my problem. If it doesn't improve the current quality of the code by the current scope of what the code solves for me, right, by the use cases I actually have to implement following the client specifications, then don't do it. Then you ain't gonna need it. And don't tell me you will need it in the future, because you cannot predict the future, right? Don't do over-engineering based on, oh, we might need it. Experience says, no, you don't, right? If you don't need it right now, if it's not a requirement right now, then start simple, start pragmatic. Everything else can, if it come later. Let's have a quick look and review from my experience about what is called solid principles. So solid stands for, well, first principle, a few, like 5 principles. First one is single responsibility principle. So a class or a component should have a single responsibility, should have, well, a single thing that it's responsible for, and should have a single reason to change, right? Reason to change is a good one. I talked to you before about this system test that I have, right? That system test, the first one, had multiple reasons to change, right? That was not really readable. If I say, okay, now what happens if I change my test? Oops, now it's black. Now we don't have a reason to change anymore. If you imagine you had your class and your method there, and you say, okay, now what is the reason to change? The reason to change might be to change the test scenario, right? If my red BMW becomes a blue BMW, right? Or if I change another test here, well, then that is a reason to change, which was already quite hard because it's buried in the code. But now actually, if the HTTP protocol changes as well to something else, that's another reason to change. And in this case, well, this violates that principle, because then I already have 2 reasons to change, right? If JSON changes to something else, then that's another reason to change. So already violate that principle 3 times. Let me just replug in that HDMI. I don't know if that helps. So that is that first of these solid principles, and this is one where I say, okay, this is really, really helpful, and we should follow. Oh, there we go. It appears on that screen. Can we put it back on the big one as well? Nice, thank you. So the second one, open-close principle, says, well, a component or a class should be open for extension and closed for modification. So if you change something here, you should, well, you should not manipulate existing what's the name, behavior. So a good or a bad example is something like a switch statement, right? If you have a switch statement with a lot of cases and jumps, well done. If anything changed, you have to modify this whole structure. So it violates the closed from modifications part. A good example is something like a plugin structure within an application, or your smartphone with an app store, right? So that's good for open. You can add, you can have some new additions. It's closed for modifications. If you download an app, you don't want your existing apps to change, hopefully, right? If you have like Telegram or your browser and you add another app, then hopefully Telegram and browser still works, right? So that is, a good way to follow that principle. I would say in project it has typically not that much of an experience or of an impact, so you might have heard of it. Similar is true with Liskov substitution principle, which says if you have an implementation or a subclass of a specific class, then the subclass should behave as in the same way like the parent class, right? If you have, for example, one method that still should do the same thing, so don't change existing behavior. So in this means the substitution part is that you can substitute any parent class with a more concrete implementation, with a more specific implementation, and the existing functionality should not change, right? The existing subclass should not do things differently. This principle is especially important if you do modeling, something like a more concrete, cars and other things like that. If you have a BMW car, then a German car, and US car, these cars, US cars should behave in the same way like a normal car. So then you care about it. Other than that, it's I would say not super crucial of a principle. Interface segregation principle says that if you have interfaces of some specification, and if you have more complex interfaces that, for example, include multiple methods and things like that, you should segregate that into smaller, more fine-grained interfaces that you can use atomically. I would say, from my experience in project, that does typically not apply that very often. It depends how your modeling looks like, but I wouldn't care too much about that. Last principle, dependency inversion. That's an interesting one that is basically dependency injection, or that being applied. So to say, well, basically, don't call us, we call you, and that heavily relies on that abstraction. So for example, if you have an add inject or an add autowired, you basically, inject some other dependency. You don't create the instance of the other class that you're about to inject, but you just tell, in this case, the framework how to use that, right? So that's basically dependency injection at its best. So you might have heard of them before. Comments, code comments, and when to use them. That is also a very interesting thing, or an interesting, I would say, interesting pointer that tells you, well, do you need comments? Or there's also, I could have written no comments. Typically, it's, I wouldn't say a code smell, but a comment is something that should be, obviously telling you that there is something there, right? So if you comment something that is obvious, you should delete the comment, right? Something like, I don't know, return 5, or it's to say, fill tank, and then you say, fills the tank. Okay, Captain Obvious, right? That is, thank you, that is very, very helpful, because actually the method already says that. So whenever you find a comment like that, just delete it. Whenever you have comments like things that I wrote into my end-to-end test, that is actually very helpful, because that appears, this comment, typically above code that is more complex. And then what I do, I take the code, extract the code into a method or another class, and use the comment to name that method or the class, right? If you say create car, order with blah, 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 and then I have tens of lines of code that do all kind of cryptic things, then I take these 10 lines of code, put a method into it, and say, okay, name the method create car, right? Because that's what it does. If you have to use some higher level naming or some higher level explanation for a low level thing that you do, then please use delegation and extract that low-level thing into a method or into a class, and name the class or the method like the comment that you had. So this is very, very helpful, where comments can actually point you to a better naming. Other than that, a comment should be an exception. So what I like is the saying, I don't know who said it, put the what into the name, put the how into the code, and put the why into the comment. And sometimes it's so obvious that there is no why, because it's obvious, right? So that means if you have some objects, some identifiers, put the what into the name, right? What the object is, a car, fill tank, I don't know, constant of pi, put that into the name, so name your identifier as that, right? Put the what and put the how into the code, well, that's obvious, and put the why into the comment. So if there is no further explanation why you do a certain thing, that should be commented. If there is no such thing, well, then get rid of the comment, right? So comments should be the exception, and then should explain well what you're actually commenting. Other than that, some comment pointers are, for example, if you have to outsource something into a constant and then name the constant, right? If I say something like, I don't know, int or double, like this, and then I have a comment where this is, that's pi, right? Well, then I should extract that into a static variable that is called pi, right? So then I can take the comment and put it as a name. So just as some hint. So comment should be the exception, and that is from experience quite a good pointer. All right, now to some key takeaways here. How to tackle that, the topic of design principles. In general, try to be pragmatic and try to solve the business problems first by using, first of all, plain Java, and then using your business domain, solving your business domain in an object-oriented approach. Modern enterprise Java, enterprise frameworks, if we're talking about enterprise, help you a lot. You can just use some annotations and some declarative mapping on top of these classes. This works really well, and then you're good to go. Then always try to delegate and craft proper abstraction layers, also in the test. So this is test scope, why I showed you that example. A few other things, favor immutability, or if you can't because of framework limitations, then at least effective immutability. And when you craft these abstraction layers, try to avoid leaky abstractions, and this think first or write on paper first or comment first principle can help you by diving down the abstraction layers from top, to next delegate to next component. Another very important one, you ain't gonna need it. I think that's a good principle. And in general, it's more important to care about the design approaches first and then only technology or implementation choices. Was the same when how to model and how to build up the architecture of an application, that it should reflect the design, the business domain, what we care about first, and then only things like is it implemented in Java or Spring or Java EE or something else. So I think these are key takeaways that help you. And I have some books as well that I really recommend it to read. I also shamelessly put in my own book on Java EE applications that help you to implement these design principles, especially with modern EE approaches like CDI, like Java EE and JPA in general. And all of these other books, I can recommend all of them to get better at designing and doing that. I hope that was helpful. Spasibo большое. Thank you very much for your attention.
Sebastian, also thank you very much.
Thank you.
And as usual, if we have some question, please ask it right now. We have some people. Yes, the third row. The first row, 30. Yes, please. Just one by one, okay? Let you begin. Yeah, okay. You can continue. You can begin, please.
Hello, thanks for the talk.
Thank you.
I have a question related to domain-driven design and like existing frameworks like Spring and Hibernate.
Yep.
So sometimes if you want to implement some complex logic in the entity class, you would like to inject some dependency, or like mappers, like factories, and it's like not so easy with Spring. And do you know some best practices, or how did you do it?
Yeah, that is a very good point, and that is often, often cited limitation of these frameworks, especially when using entities. So yeah, that's very correct, and I ran into the same issue myself many times. That might be a pointer that something, well, it's a little bit too complex to be implemented in an entity, and you would implement it in a service instead. It depends a little bit, what is the best approach. What it could do then is actually to, sometimes that helped. It depends a little bit on the modeling. If you say you model another component, that might be something like a service, but you call it in in the same way like your business domain would, call that problem or solution or something like a, I don't know, car maintenance log, and that might be, for example, a Spring component, and then just pass the car, for example, to it. So have something like, this freeway structure in order to solve that. I ran into this issue myself, so yeah, that's one of the limitations you have, unfortunately. Then in order to solve that, I would say, create a different Spring component or Spring service that then is implemented to you. I think that's the best approach in this case. Unfortunately, I mean, you're right with the modeling. Yeah, thank you.
Yes, you're welcome.
Hello. I have a question about screaming architecture section. You showed us REST layered architecture and then domain-driven architecture, like you had REST layer, service layer, and then cars, orders, and so on.
Right.
And this is single microservice, as I understand.
This will be a single application with, the Java packages. So this is, Java packages. These are directories, what I showed you, within, source main, just for example.
Okay, but if you have cars, orders as single microservices, do you still have layered architecture in a single microservice with a single responsibility, or you still have domain like in packages?
I still have the domain approach with the vertical layering also inside a single microservice, because typically I have more modules than just a single one, right? I had cars, I had maintenance, I had, I might have other things, even if, if it's just about, let's say, cars or orders. So typically that is the case, that I actually have multiple, packages for then cars, then maybe tires is, big enough to be its own package, and then I would use the same structure.
Okay, thanks.
Thank you.
All right, who's the next one? Yes, you're welcome.
Hello, thank you for your presentation, and my question related to namespacing and package naming. It's pretty good to use naming structure for domain, but when we create, for example, order, and we create finished state machine for this order that is distributed by some domain and driven development via different services, and
so you distribute these classes among multiple applications?
It depends on different business logic on it, and it's for example, we have one service just for creating car, just for management order, and so on and so on. And so when we create some package like okay, it's order, but it appears finished state machine of order. It creates management of orders and some, I don't know, maybe interceptors and so on and so on. This package that might have contains just order. It's just contains finished state machine, blah, blah, blah.
Right, and also contains other things, and then you basically leak the implementation detail or the framework detail into this shared package as well, right? Because then you want to add some interceptors and maybe some, JSON-B mapping annotations like Jackson or Yes. That is actually the reason why most detailed projects don't do this. Don't share anything. So for me, microservices also shared nothing architecture with don't share anything on the implementation side. Because in theory, and this many companies try that, in theory this sounds always nice, and we can reuse things to not, duplication is evil and things like that. But the detail, there's a German saying, the devil lays in the detail. In the detail, it always fails if you say, oh, now actually we want to change the Java version here, we want to change the framework and, add some other different annotation that's not used in all of the applications. What you do by doing that, sooner or later, you always tangle the whole set of microservices together with this implementation detail, and then you're not really doing microservices anymore because the implementation detail is then shared among all the services, right? It's very similar to have something like a common shared database schema. Same thing with the modeling there. You just couple all of that together, and then you're not independent anymore. You can reuse things. What I would do instead actually is I would copy that over. If you say, we have the same implementation here, and then I copied it to another team that uses Java as well, but starting from there, they're independent, right? And then you also have to do, some contract testing, contract verification. If, for example, you expose that via HTTP and REST, and it's then just, like safer to do that. And ultimately it will not, from my experience at least, it will not work, because sooner or later you have to change something in that. So in general, as a recommendation, I would actually avoid it and rather have some duplication rather than reusing things and sharing things over multiple microservices. Same for data, same for classes and implementations.
Okay, thank you.
Thanks.
Yes, you had this business logic, like methods in the entity. And I often see this layering. So we have a copy of this entity class with slight different annotations and maybe otherwise the same. One's for the JPA layer, one's for the service layer, and one's for the REST layer. And then you have this issue, you don't want something like methods that really do something in there, because then you might have to duplicate them also, or just put them in the service layer or so. What do you think about that?
What I think about it, if I can avoid it somehow, I would always avoid duplicating these entities actually within one application. Right? So if you say you have some, horizontal approach, like this cares about REST, this cares about the DAO or whatever, I would always start with a single car class that is reused, that resides in, entity package or something, that is reused within my whole module or the whole application. And then you can start with a simple approach, again, pragmatic, right? If you say you can expose that via REST and then just put some JSON-B annotations, if it works for you, great. If you have to expose some other information, well, then you have to have another mapper, but then you have to reason because the structure's changed. It's not anymore the same thing. And that makes, I would say, more sense, or it starts more from a pragmatic perspective. You ain't gonna need it, right? Don't introduce multiple classes if you really don't need them, right? So I would say this is more the big pragmatic approach. Thank you.
Do we have somebody who wanna ask something else? Anybody? Waiting, yes. There is one person, please.
Ausgezeichnetes Gespräch. Dankeschön. So the question I was about to ask is about this vertical packaging. And it sounds to me like a bounded context somehow.
Oh yeah, absolutely.
So you have like multiple packages, but if you go a bit down, you still have to package it like in layers, I think.
At some point you might, if you get too many classes within a single, like cars package or something like that, but typically that doesn't even happen that often, because seldomly it's more than, I don't know, 8, 9, 10 classes within a single, responsibility of cars, for example. Or what I rather would do is to say, okay, you have cars, and then you have more classes, so then you introduce, cars, tires, engine, and package it in that way. Right? And then you might have a car service, a car repository, and the car class within that package. If you can start with that, that's great. What I would do actually, instead of the technical horizontal layering, which is also horizontal, is something like a boundary control entity pattern that says, okay, this is the use case boundary within the class, within the car service, for example. This is the entities of the car, of the tire, of the engine, and then a control for the other services that are involved and the repositories. So then I would maybe use that approach. But other than that, I would keep it as as vertical and as business driven as possible, because that's just easier to understand typically.
Yeah, and from one perspective, it's easier to understand, but if you have a team of developers, and it depends what do you want to achieve, more understanding from the customers or from the technical guys. Because if the team changes and, yeah, they understand the domain model, but then there are different architectures. Clean architecture, for example, is use cases, interactions, etc., gateways.
Yeah.
And I think it makes it worse for developers in the end.
I wouldn't say so. So it depends on the team, but typically, especially if you're in the microservice environment, you don't have the separation that one developer is responsible for only databases and one developer only does REST interfaces or something like that. But you more likely, at least from my experience, have the approach that you say, okay, let's change something what car is managed, and then you have to modify car service, car repository, the database to car table and the car entity. But seldomly you say, oh, we modify all, I don't know, all DAOs, all entity, all repositories or something like that at the same time, right? So I think this corresponds very much with the approach of modifying a module or a part of the domain at a time, right? A coherent module. from the developers, right? Because they typically work that whole stack of, from the boundary to something like a gateway or to a database.
Okay, thank you.
Yeah, thanks.
All right, and the last question, please.
I have a short question. For example, use case. If you have a certain product and this product has different variations, variation actually extends or reusing the product's properties. How would you deal with them? Would you create a new package for this, or according to this domain-driven design?
Right. That really depends, and that is good that you mentioned product, because once you build a product, then a few other, few things apply a little bit differently. So then sharing of, of classes or of packages that you share with multiple, different flavors, if you want, does make sense, right? It typically does not make sense to split an application that will always be deployed in a single application into multiple modules or into multiple binaries, right? Because you ship it as one implementation always. But in your case, if you say, oh, customer A gets this flavor, customer B gets it differently, then it might make sense to, modularize your application into a core and then into a different module and different flavors, or to use even something like a plugin structure. If you have to be more, customizable, something like that, then modulating is where it actually would start. But don't do that if you have just a single, always the single deployable, always the single binary. So this is why I mostly tell people to not do it, because from my experience, it's mostly done when you would not have to do it rather than the other way around, right? But in your case, I would look into how to structure it and then try to extract the parts of the module that you can actually reuse within these multiple flavors for the multiple customers, I would say.